talk about triggers and constraints and keys, is that what you have, triggers are basically going to be, if I update, delete, or insert a record, then here's some extra things that need to be done, which is usually, it may be cascading kind of functionality. So if I delete this record, I need to delete its related records. It may be essentially a timestamp kind of thing that says, okay, if I insert this record, I need to somewhere create an, either set a value or insert a record that says that this record was created at this time, or this record was updated at this time. Or even sometimes it's, this record at this time was updated with these values. There's also going to be constraints. There's going to be things where you can't, there's certain records that you're not going to be able to delete unless you first delete a parent record or records that are pointing to it. And sometimes this is by design for the data integrity. Sometimes there are going to be these constraints, and even some of the triggers are going to be essentially they're security and permission related kinds of things. So there may be fields in a record that are not supposed to be updated. They're only updated by maybe some triggers and constraints as opposed to directly updating them. And this becomes, again, where you're going to have to look at the requirements and see how it's laid out. Because it may be that there are restrictions to how data is inserted or updated. It may be that there should be no direct way, which is not uncommon, where there'll be cases where there's no direct way other than within the database to change certain data. And sometimes even within the database, unless you have a specific level of access, then, where basically you have to, essentially like turn off triggers or constraints, you're not going to be able to change the data. So security can be application level that you would see and deal with as you normally do. But sometimes you're going to run into such things down at the database level as well. So it's not only in the save and load, going back to that idea a little bit, of making sure that things that you want to change. There's things that shouldn't change and making sure that they don't. Sometimes it's as simple as a create versus an update timestamp. You'll see bugs where every time you update, it updates the created timestamp, which is incorrect. You actually need to, you want to have a timestamp of when that record was first created, and then separately you have something that shows when it was last changed, when it was last updated. And so on an update, you don't want to see that creation date change. And this stuff, again, can be very complicated, and you may have to have very specific tests that you're creating to validate those kinds of those restrictions. And when thinking about triggers, constraints, and keys, I've sort of touched these, but I want, from a bullet point of view, it may help a little bit. Is that one, sort of here in the top right, you really need to deal with updates, inserts, and deletes. Those are really the three main actions that may have related triggers and constraints. And so you have to consider each of those three actions almost with every record or table, and how you want to test that and verify it. There may be side effect requirements, which are your triggers, your constraints, related keys, and things of that nature. So an update may not be as simple as I just check those couple of values I updated. There may be other things I have to check to make sure that those side effects that happen when data is changed are properly being done. You always have to do null testing, essentially, empty, invalid values, invalid relationships, missing data, partial data. And that can be, sometimes it can be very, very detail oriented, very just tedious, because there's just a lot of data. If you've got a field that's got, record's got 20 different columns on it, then you may have to do effectively, at least 20 different tests, or actually be way more than that, for each field, testing, what if I set something invalid? What if I set something empty? What if I do the happy path? And with all of these that we've already talked about, there needs to be the proper messages or notifications that are involved with this, because sometimes these things are written and it's just, if it breaks, it breaks, and then your application's dead. But typically what should happen is there should be some sort of a response that comes back so that you can see that, hey, this is invalid data that was attempted to work with. You need to, with the testing, one of the challenges, sometimes there's going to be unique values. I think in current world, a lot of times it may be a phone number, but it may also be like an email address that, based on the requirements, these things need to be unique within your data, within the sets. And it's a challenge to generate all of those unique things. Now, the nice thing is that there are key generators and unique ID generators and things like that. There's some random tools out there. Actually, even we have an app that we talked about way back that is our own little random data generator built for databases to put random stuff in. And we need to be able to do that sometimes to get a valid amount of test data. But then when we do so, we also need to make sure that we're tracking the IDs that were generated, because we're going to talk about cleaning up later. And we also need to make sure that we did not have we sort of like where we miss coverage in our testing by using too much of the same thing. So, sometimes they're like, for example, testing a user, we use the name like John Smith or John Doe a whole lot. But you also want to test other things, is maybe throw some special characters like that you would see, like a hyphen, a comma, things like that within a name. Maybe you also want to do like longer, shorter names. What happens if it's a first name, last name versus first, middle, last, things like that. That you do see these in other testing, but it's much more prevalent in the database world because we're dealing with the data itself and the formats of it. And all of this I've related a couple of times, I've mentioned this a couple of times, is the whole idea of cascading updates and changes. So there are potentially other records that are going to change based on the update that you made. It may be that there's like an address record somewhere that needs to be changed. There may be something that says that this record changed. So you may have to go to some other table in the database and make sure that the change that you made was properly recorded. Again, this goes back to the requirements. And challenge on all of this is that it is not uncommon for the requirements to be sparse related to how some of this stuff works. That it's the kind of stuff that is not uncommon for there to be things that are missed. And it's not until you start testing it and you say, hey, I had this happen. What is that supposed to work? Is that not supposed to work? How is that supposed to work? And so sometimes you're going to have to go back and basically validating requirements as part of going through the database testing. And I've mentioned these, but now specifically audit logs and tracking. When we're doing updates, like I said, often there's going to be some sort of trigger constraints and things that make sure that records exist, that they don't exist when they shouldn't exist. And along with that, we're going to have some timestamps and maybe other logging that says this data was created at this date, maybe by this person. So not just timestamps, but some sort of a user ID needs to be part of that. And in part of your testing, you need to make sure that the user IDs that are tracked works for the valid users being able to do that. This may even include permissions inside the data itself. So you may have a permission table somewhere that you need to make sure that this person can update this if they have this, the correct permission. And then if they don't have that permission, that they can't update or create that record. And again, it's going to go back to requirements and making sure that those are laid out properly and that you can test and validate those properly. There's usually going to be differences between inserting or creating records and updating records, modifying records, and make sure that the side effects related to that, the audit logs, whether it's a text log file somewhere or It may be a database table somewhere. It may be fields within that record, or it may be a whole other table that provides that audit log. There's things like shadow tables in that, where it's essentially as a record is modified in one table, there's a record entered somewhere else in this shadow table that says this record was modified at this time. Here's how it was modified. So you need to make sure that those are properly being logged, those entries are being created properly. It may be a database change, it may be a file, it may be both. So there may be some sort of database level logging that you want to verify. And this is sort of, you want to verify that it is displaying the things it needs to, but also in a security, in a world of HIPAA and all these other requirements that are out there, you want to make sure that the values are not in a log file that shouldn't be in a log file. So for example, you don't want to be able to look at a log file and see valid credit card numbers. That should not exist. You don't really, and if it does, if there for some reason that's needed for some sort of logging, then that needs to be properly secured, all that kind of good stuff. So you want to make sure that, and it sort of goes back a little bit back to that encryption concept. Values that should be encrypted, you need to make sure that they were properly encrypted in the database. So if I save a password and it's supposed to be, I'm the only one that ever knows what that password is, I should not be able to go look in a database table somewhere and see what that database or what that password was. And you need to verify, this goes back to really your relationships within the data, is make sure that when the audit logs and you're verifying those, that it's also the user IDs or names are properly being tracked. Again, it's not uncommon that you'll have sort of essentially a hard-coded value somewhere where everything is, and it may not even be hard-coded, it may be how the application works, that the application logs in as, like the super user for the database. And all the transactions are then based on that super user, as opposed to the actual user, that, like if it's me and if I make a change, I need to make sure that my name, my ID is tied to that change, as opposed to it just being the super user. And that's, again, not an uncommon occurrence where the application connects as a certain user, and then you see all the audit trails just show that user making the changes, that application user, as opposed to an actual logged in user that's not just the application, but it's a person that you can tie that back to. And again, it goes to the idea of what I put into the database, I need to be able to get that back out properly. So if I know that Rob is updating this data and I need to have audit trails based on that, I should be able to get back out of the database that Rob made this change at this time. And again, this goes back to your requirements as well. Making sure that you understand them and that they properly detail what needs to be done within that. Cleaning up your mess. This is often one of the biggest challenges. One is having test data that works or that matches needs. Sometimes test data is just a handful of records when what you really need to test is at scale. So you may need to have maybe even millions of records available for your testing to make sure that you can test the performance, make sure that things work even in what's going to be at least close enough to the production environment. And it's not uncommon in the database world that it works awesome when you've got 10 records in there. It does not work at all when you put 100,000 records in there or 1 million records in there. So you need to have properly sized test data as far as amount. But then we have the cleanup aspect of, if I go in and especially whether it's, I guess it really doesn't matter whether I manually do it or script it, if I run tests and they change data or create data or delete data, then there's going to be audit log entries related to that. There may be test data that's now sitting around in my database. So part of our cleanup is we need to have, ideally, and sometimes it's not possible. But for the most part, we want to be able to roll back those changes so that I can go in, I can create, I have sort of a test script, but then I have a cleanup script that goes back, and for everything that I just did in my testing, it's going to clean that stuff back up, either mark it inactive or delete it if that's possible. Ideally, I want to be able to remove the audit trail of that as well, because if somebody's doing audit trail research, they don't want to have all these test entries that they're having to dig through. So sometimes I have that side effect of data changes that I need to take into account as part of my cleanup. There may be, in some cases, there may be auto-generated values, keys, and things like that that are generated that I now want to reset those counters. For example, if I am starting from essentially a clean database, I may have this integer-related ID that starts at 1. And if I go in and do a bunch of testing, I don't want it now to start at 4,058, because that's how many test records I created. So I may have to actually go back and reset some of those counters and ID generators. That's not as common. It shouldn't be an issue, but sometimes it is, particularly with regard to smaller data sets that are essentially lookup values. Like if you want to have, if you have like account types, let's say it's a financial system, and you have these different account types, and there's only 10 account types, well, you may find it much better to have those account type numbers at basically 1 through 10. And if you're doing a bunch of testing related to that, you don't want it suddenly to blow it out so that the numbers are non-sequential and are in the thousands or higher. You may not be able to fully clean up. So instead, you may need some way to tag your test data. Sometimes this is easy to do. Sometimes it's a matter of maybe there's a note or description field or some sort of free text enough that you can put the word test in it or something like that, or test record, do not touch, test account, do not use. Sometimes it's certain ID values. So you can go back and maybe make sure that stuff is tagged in a certain way or configured in a certain way. And it may be that how you do it, you just need to communicate that when I test, these are things that are tags or markers, so you can tell that this was test data and not something that is, we'll say, real data. The idea of a test image or a staging image or even data reloads is becoming, I was going to say it's gotten a little better, but sometimes now with cloud databases and things like that, not as much. Because when you're dealing with a cloud database, sometimes there's a cost to those transactions, and it's expensive to run all those tests and then run a bunch more transactions to clean it up. One way to get around some of that is to basically drop a database and rebuild it. Sometimes that's really the approach you want to take, is that you want to, before your tests start, do a database backup. You go in, you run all your testing, and then when you're done, and your cleanup is simply that you restore the database from that backup point that you took. Sometimes that's the easiest way to get around it. It's just, let's skip all the trouble, and I'm just going to back it up. And when I'm done, I'm going to restore the database. In production, that may not be feasible, but particularly with the idea of if you have a test database, that may be something that you look at. Maybe it exists, and if not, maybe you recommend it, that there is some sort of a test image. In some cases, specifically with continuous integration and development, deployment, there may be a database image that is just reloaded on a daily or weekly basis. So when I do a build, maybe one of the things I do is I just go restore a pristine version of the database, make some database, if there's changes that have to be done to that database, I make the changes, and then I, boom, take a snapshot. And the next time I want to get a, call it clean database in quotes, then I just reload that image. That may or may not be feasible, but a lot of times that's going to be the best and most efficient way to do it, because then you don't have to deal with what did I change. You just go back to that, essentially that save point.